This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we will be looking at an outline of future videos, and we will also be looking at some definitions in number systems. Future videos will include number systems, indices, arithmetic, length, area and volume. More information on these can be found on curriculumonline.ie. So to begin, we'll start with a definition of the natural numbers. So these are the set of counting numbers, not including 0, denoted by this squiggly capital letter N, and listed below. Next, we'll define the set of integers, denoted by our squiggly letter Z, and this is the set of all positive, negative whole numbers, including 0. Interestingly to note about 0, that 0 is an even number and is neither positive nor negative. Next we have our rational numbers, denoted by our squiggly Q. This is the set of numbers that can be written as a fraction of integers. The number on top is called the numerator and the one on the bottom is called the denominator. The denominator must not be 0. The irrational numbers then are any number that can't be expressed as a fraction of two integers such as pi, e, root 2 and root 3. It is believed that root 2 is the first number to have been proved irrational by the ancient Greeks. The irrational numbers have infinite decimal expansions. So root 2 is equal to 1.4142 and so on, and this will go on forever. And no matter how close a rational number gets to root 2, it will never actually equal root 2. So we can see that below on the number line. Root 2 is represented by the blue line, and the fractions will get ever closer to this blue line but will never actually equal the blue line. When we talk about irrational numbers, we have non-terminating recurring decimals. So in an irrational number, a digit or block of digits repeats itself in the decimal part when the irrational number is called a non-terminating recurring irrational number. So for example, we can see 1.66666 and so on, or 0.141414 and so on. So often on a calculator, a bar or a dot is used to represent the fact that these will go on forever. So we can see 1.41414, etc. is equal to 1.14 with a bar across the top. What this means is we repeat the 1,4 section over and over and over again, and the same can be said for the 1,4 with the dots on top. We repeat these two numbers in that order forever. We also have non-terminating and non-recurring decimals. So this is when an irrational number is non-repeating digits without any pattern in the decimal part. Then the irrational number is called a non-terminating and non-recurring irrational number, such as pi or root 2. Root 2 being 1.4142 and so on and so on. The real numbers then can be defined as a set of all rational numbers and irrational numbers. This will encompass all of the numbers listed previously. So we can see here on this diagram we have 4 circles representing the natural numbers, the integers, the rational numbers and the real numbers. It's important to note we can see already from this diagram the natural numbers are contained within the integers, which are contained within the rational numbers, which are contained within the real numbers. Another important thing to note is that this is not reversible. So the integers are not contained within the natural numbers, the real are not contained within the natural numbers, and so on. So we can see some examples of natural numbers: 4, 29, examples of integers being 0 and -1. Some rational numbers we can see represented by fractions, and some real numbers we can see represented by root 2, pi, and fractions with irrational numbers in them.